we continue looking at binomial expansion using this formula here. Now, in our previous video, I asked you to expand x plus y to the fourth using this formula for the binomial expansion and pretend as if you did not see this thing here and did not know that it was the expansion. What we're going to do is open up a new page, and then we're going to look at doing it without looking at what we're seeing here. But before I open up that new page, let me take a screenshot just in case anything goes wrong. Okay, I happen to open up the new page without incident. So we have a blank page to work with and we can check back on this. Here, on the new page, I'm going to write x plus y to the n equals. So the formula is x plus y to the n equals, it's n c r x to the r y to the n minus r. And we have x plus y to the power of 4. So we have x plus y to the power of 4. We're going to expand this, and then we check back on the other page to see if we have everything correct. So here now, the values, the x's and the powers, you have x to the fourth, so then we have x to the 3, x to the 2, x to the 1, x to the 0. For the y's, we have y to the 0, y to the 1, y to the 2, y to the 3, y to the 4th. We'll be adding them. So we're plussing here. Alright. Now, we know that the number that will multiply the first and the last will be 1. So it's 1x to the fourth, 1x to the fourth, yeah, 1x to the 1y to the fourth, because after a while I'm going to rewrite it without the y to the 0 and the x to the 0. But this will be 1 and this will be 1. But we want the number that will come here and here. Now, looking at the formula, it's n c r x to the r y to the n minus r. We know we're expanding to the fourth, so n is 4. So n is 4, n is 4. Alright, here we have x to the 3, so r is 3. So we get rid of this and write our 3. This r also, we get rid of this r and write our 3. 4 minus 3. What is 4 minus 3? 4 minus 3 is 1. So the 4 minus 3, that amounts to 1. Now notice we have x to the 3, y to the 1. Good. This will give you the number. Oh, r here. We said that r was 3. I didn't change this r to 3. Alright. What we have is 4c3. Now remember, ncr is equal to, this is another formula. Let me box up this one. Nicely wrap it and nicely wrap this one in another box. Good. NCR is n factorial over n minus r factorial r factorial. So those are the formulas we're going to be using. This one is for the binomial expansion on the left. The one on the right is for the factorial, the combination, right? Now, NC4. This is equal to 4 factorial over 4 minus 3 factorial, 3 factorial, which is, it will be 4 by 3 by 2 by 1, that's 4 factorial, over 4 minus 3 is 1. 1 factorial times 3 factorial. 3 factorial is 3 by 2 by 1. But 1 factorial is just 1, so we just make this remain 1. 1 times anything is that itself. So we can just take off the 1s. Because whether we multiply them or not, they remain the same. Those cancel. You have 3 by 2 cancel 3 by 2. So it seems as if the number that should come here is 4. Now, what is the number that should come here? Now, here, NCR. We have NCR again. Oh, NCR x to the r, y to the n minus r. This says x to the 2, so r is 2. So let's get rid of this r and put 2, right? This r as well, we get rid of this r. And put 2. After that now, we say, oh, this R2, don't want to miss out this R here. So we get rid of that R, and we have 2 there. Good. N is 4. You're raising to the power of 4. So this should be 4. And this 4 as well. So this will be 4. So 4C2 is 4 factorial over 4 minus 2 factorial 2 factorial. 4 factorial is 4 by 3 by 2 by 1 over 4 minus 2 factorial is 2 factorial. 2 factorial is 2 by 1 times 2 factorial again is 2 by 1. So if we're going to find out which number should come here. Up top here is 4 3 is 12, 12 2 is 24. So it's 24 over 2 times 2 is 4. But 4 into 24 is 6. So there should be a 6 here. Now what number should come here? That's the next thing we want to see. Let's erase these. Which number should go there? What we have here is x to the 1, y to the 3. The formula says we have NCR, x to the r, y to the n minus r. What we have is x to the 1, y to the 3. The fact that you have x to the 1 means r is 1. So we replace this r with 1. This is an r2, so replace this r with 1. Nice. N is 4 because we're raising to the power of 4. It says x plus y to the n. So n is 4. So this n, we replace it with 4. This n, we replace it with 4. Alright. We said r is 1. Keep forgetting to change this r as well. Alright, so that will be 4 factorial over 4 minus 1 factorial 1 factorial times x to the 1 y to the 3. And it's x to the 1 y to the 3. Now this is going to give us the number that should come here. 4 factorial is 4 by 3 by 2 by 1. Divided by 4 minus 1 factorial is 3 factorial is 3 by 2 by 1. And that is multiplied by 1 factorial, which is just 1. So 3 by 2 by 1 cancel 3 by 2 by 1. We have 4 here. So it is 4. So let's check now to see if we're correct. 1x to the 4, y to the 0. So 1x to the 4, y to the 0. Good. 4x cubed, y to the 1. 4x cubed, y to the 1. Nice. 6x squared, y squared. So 6x squared, y squared. Okay. 4x to the 1, y cubed. It says 4x to the 1, y cubed. Good. 1x to the 0, y to the 4th. X to the 0, y to the 4. Right, it is correct. So, finally, if you were writing this all down, you could leave out the x to the 0 and the y to the 0 and the power is 1. Right? And what you would get is x to the 4th plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the 4th. That is what you get when you expand x plus y to the power of 4. So you see that? Alright. Now let's go back to our previous screen. Let's erase some of these things here. Now, what I want you to do is imagine that you did not see this, you don't know anything about this, and you are asked to expand x plus y to the 5. You're going to expand x plus y to the 5. Let me just erase what I don't want to erase the formula. Let me erase some of these things I have here. And this would be x plus y to the power of 5. Expand x plus y to the power of 5 without looking back at what we did previously, without using the Pascal's triangle, and we see what we get. We'll go through it together in the next video. So I will see you then.